Welcome to my class. Today we will discuss about 2 points. First one, that is electrostatic potential energy, and second one, that is electrostatic potential energy difference. But before starting this topic, first let us recall some basic concept of class 11, and you have studied in class 11 the concept of work and your conservative force, and the concept of the potential energy. And you also know in the class 11 your gravitational potential energy and elastic potential energy, and in class 12 we will discuss about electrostatic potential energy. Clear? So that first we discuss about your work. You know the definition and the mathematical expression of the work. What is work? Suppose a body is there, initially placed at point R. R is the initial position of the body. Then some sufficient external force is applied on the body. If sufficient external force is applied on the body, then what happens? Suppose the body starts to move from the initial point R to the final point P, and this is the total displacement of the body. Suppose total displacement, we write that is R. Here force is applied, displacement is there, that means work is done. Work is done by the external force, and that work done we write W is equal to force F dot S vector. If displacement is R vector, we write this is equal to force F dot R vector. Clear? If we take a very small displacement, suppose this one, suppose this point is your A point, this point is a B point, and distance between A to B, suppose very small, that is dr, then work done is also small, and for small work done we write that is dw. Dw is equal to F vector dot dr vector. This is dot product between the two vectors. Dot product means that is also known as the scalar product. So that work is a scalar quantity. You know that work is a scalar quantity. That means when the body moves from point A to B, work done is small, that is dw. We write that is F vector dot dr vector. But if the body moves from point R to P, then we write the work done, that is the total work done, W. W is equal to integration of dw, an initial point that is R and final point that is P. So that we write finally this is the work done. When body moves from point R to P, we write that is WRP is equal to integration of force and displacement, and that is known as the integral of a force over displacement. Integral of a force over displacement, that is the work done, and you know this expression. Here R is the initial position and P is the final position of the body. Similarly, second point, you know all about your conservative force, because generally forces are divided into two parts, into two types. One is your conservative force and another is your non-conservative force. Then what is the meaning of the conservative force? What is conservative? Very simple. Suppose here body is situated at point A. A is the initial position of the body. Force is applied on the body. Force is applied on the body. Then what happened? Suppose the body moves from point A to B along the path 1. Body moves from point A to B along the path 1. That means displacement is there. Force is there. So that work is done by the external force. And we write that work done is equal to WAB along path 1. Similarly, in the second case, same thing. Same body situated at point A. Force is applied on the body. Sufficient force is applied on the body. Then the body starts to move from A to B along the path 2, not 1, along the path 2. Then also displacement is there. External force is there. So the work is there. Work is done by the external force. That means suppose when work done by the external force along path 1 is equal to work done by the external force along path 2, both are same. Same work is done when the body moves along path 1 and also moves in path 2. Then the force is known as the conservative. That means work done by the force is independent of the path. Work done by the force not depend on the path. That is independent. If work done by the force not depend on the path, then we say that work done by the force is only depend on the initial point and final point. And this type of a force is known as the conservative force, and this is the definition of the conservative force. And you also know that different types of conservative forces are there. First type, that is the force of gravity. Force of gravity, that is the force between your earth and any body. Suppose an object is there at a distance r from the surface of the earth. Then force is applied on this object. That means if we release the body automatically moves in the downward direction towards the surface of the earth. And this force is known as the force of gravity. So that force of gravity, that is a conservative force. Similarly, second one, that is your elastic force of a spring. Suppose you take a spring, and in this case, if you apply the external force, then the length of the spring is gradually increased, and in this case, elastic force is there, just in the opposite direction of the external force. And that elastic force in case of a spring, that is also known as the conservative force. And another is your Coulomb force. Coulomb force is the example of the conservative force. Coulomb force means that is your electrostatic force of repulsion or attraction. That means if we take two charges, then there is a force of repulsion or force of attraction between these two charges. That means force between two charges is known as the Coulomb force, and these are the examples of the conservative force. And another term is there, that is the third term, that is the concept of the potential energy. Concept of the potential energy, you know gravitational potential energy, elastic potential energy in class 11. Then what is gravitational potential energy? This is the diagram. This one is your earth. Suppose initially a body is there at point R. Point R is the initial position of the body. If a body is placed at point R, then one force is applied on the body, that is the force of gravity, and this is the direction of the force of gravity. That means Earth attracts the body towards itself. This is the force of gravity. Suppose we applied an external force on the body just opposite to the gravitational force. Just opposite to the gravitational force. If gravitational force is positive, suppose if gravitational force is positive, then external force is negative, because both are in the opposite direction. And magnitude of this external force must be greater than the gravitational force. Magnitude of the external force must be greater than the gravitational force, or may be equal to the gravitational force. Then what happens? Suppose the body moves from point R to P against the gravitational force by applying the external force. If the body moves from point R to P, R is the initial position of the body, P is the final position of the body, then here external force is there, displacement is there from R to P. So that force is there, displacement is there. That means work is done by this external force. And work done by this external force is stored as potential energy of the body. This work done is stored as the potential energy of the body. Suppose at point P, body is at rest. If a body is at rest, its kinetic energy is 0, because you know the formula for the kinetic energy. Kinetic energy is equal to half mv square. If velocity is 0, then kinetic energy is automatically 0. That means at point P, the energy stored, that is the potential energy. That means all energy as the potential energy. No kinetic energy is there. If we release the body from point P, the body moves in the downward direction due to the force of gravity. If the body moves in the downward direction, its velocity is gradually increased. If velocity is gradually increased, automatically kinetic energy is increased. If kinetic energy is increased, its potential energy is gradually decreased. That means if body moves from P to R or towards the surface of Earth, some potential energy is converted towards the kinetic energy. But always sum of kinetic energy and potential energy remain constant. You know the conservation of energy in class 11, that is the conservation of energy. And in this case, this is known as the gravitational potential energy. But in this chapter, we will discuss about your electrostatic potential energy and potential energy difference. Before discussing this topic, we may take two assumptions. What are these? Look at the figure. O point is the origin. At point O, one charge is there, that is plus Q, capital Q. That is known as the source charge. Similarly, another charge is there, second charge. That is also plus Q, that is situated at point R. That is known as the test charge. Its magnitude is a Q, small q, not 1. That is not a unit positive charge. That is not a unit positive test charge. That is positive test charge, not unit positive. Plus Q is a positive test charge, not unit positive test charge. Clear? Then what happened? magnitude of this test charge is Q, but that is very small. Magnitude of test charge is Q, but we take magnitude of test charge is very small. Why? If we take magnitude of the test charge is small, then it does not disturb the original source charge. If we take a small magnitude test charge, this is small magnitude test charge does not disturb the original source charge plus Q. This is the first assumptions. That means we take a very small magnitude test charge. This is the first assumptions. Second assumptions. Suppose initially test charge is placed at point R. R is the initial position. Then what happens? Source charge that is positive, test charge that is also positive. You know, if two positive charges are there, then a repulsive force is applied. A repulsive electrostatic force is applied. In this case, same thing. A repulsive electrostatic force is applied on this test charge along this direction. Suppose this one is your x-axis and along the positive x-axis. Then we applied another external force just opposite to the electrostatic force. And what is the second assumption? Magnitude of this external force is equal to magnitude of the electrostatic force, or maybe slightly greater. We applied some external force on this test charge just opposite to the electrostatic force, but magnitude of this external force equal to the electrostatic force or slightly greater. That means if one is positive, another is negative. We write external force is equal to minus of electrostatic force. If magnitude of both the forces are same, one is taken as positive, another is negative, then total force applied on this test charge is 0. If net force applied on the test charge is 0, this is the net force. You know the formula for the force in class 11, that is mass into acceleration. Mass into acceleration is equal to 0. But mass of a charge is not 0. Mass is not equal to 0. Then from this expression we write acceleration is equal to 0. If acceleration is 0, you know, velocity always remain constant. Here we write speed is remain constant. That means when external force is applied on the test charge starts to move from point R to the point P without any acceleration or with constant speed, but that speed is very slow. That speed is very small. This is the second assumptions. Two assumptions are there. Now we will start the first point of this chapter. That is the electrostatic potential energy difference. For energy difference, we write the symbol del U. Then what is the electrostatic potential energy difference? Look at the figure, same thing. Here we take a source charge that is plus q at point O. Initially a test charge is there that is placed at point R. R is the initial position. Then electrostatic force is applied on this test charge along this direction because both are positive. Then we applied an external force just opposite to the electrostatic force, and magnitude of the external force is approximately same as the electrostatic force, so that the test charge plus q starts to move from point R to P. If the test charge moves from point R to P, work is done. Work is done by this external force, and this work done by this external force is stored as potential energy. That is the potential energy. This work done is known as the potential energy. Here we take 2 points. R point is the initial point and P point is the final point, and body moves from point R to P. Suppose at any instant of time, this is the position of the test charge, and if we give very small time, the test charge suppose moves from point A to B. That means displacement of the test charge, suppose we write dr. Then what is the work done? You know the formula. Work done is very small, that is dw. dw is equal to, we take force as the external force, dot displacement is dr. But the test charge moves from point R to P, then what is the total work done? We write total work done is equal to W. W is equal to summation or integration of all the small work done, that is dW. This is equal to, in place of dW, we write F external dot dr. An initial point of the charge particle, that is R, final point or final position of the charge particle, that is P. This is the work done. This is the work done. And this work done when charge particle moves from point R to P is known as the electrostatic potential energy. And if we take in place of the external force, if we take electrostatic force, both are in the opposite direction. Opposite direction means here we put a negative sign. Clear? And this is the definition of the electric potential energy difference between 2 points. Between 2 points. Between 2 points means when the charge particle moves from point R to P. And at point R, suppose its electrostatic potential energy, we write UR. At point P, suppose we write that is UP. And if we move the test charge from point R to P, its potential energy is gradually increased. Here source charge is positive. If we compare between UR and UP, that means potential at point P is greater as compared to the potential at point R, so that there is a difference of potential, and we write this difference of potential, that is UP minus UR, and symbolically we write that is del U. Clear? And this is all about your electrostatic potential energy difference between 2 points. Then second point of this chapter, very simple, that is electrostatic potential energy. For this we write the symbol U. What is electrostatic potential energy? Suppose R point or point R is shift to infinity. If we take the point R at infinity, then what happens? That means initially the test charge is situated at infinity, not at point R. Initially test charge is situated at infinite. Then what happens? Source charge, that is positive. Test charge, that is also positive. And distance between the source charge and the test charge is very, very large. So that a repulsive force is applied on this test charge, but that is very, very small. Then we applied a external force. Its magnitude is approximately same as the electrostatic force. So that the test charge now starts to move from infinite up to point P. If the test charge starts to move from infinite up to point P by this electrostatic force, by this external force just against the electrostatic force, then work is done by this external force. And this work done by this external force is known as the electrostatic potential energy at point P, because test charge moves from point infinite up to point P. So that this is the electrostatic potential energy of a charge at any point, means that is point P. And this is the definition of the electrostatic potential energy. Once again, suppose a test charge is there at infinite, then we applied the external force just opposite to the electrostatic force, so that the test charge starts to move from infinite up to point P. Some work is done by this external force, and this work done by the external force is stored as the potential energy, and that is known as the electrostatic potential energy at point P. Clear? And when test charge is at infinite, potential energy is 0. So that we write work done when test charge moves from point infinite to P is equal to integration from infinite to P of a force dot dr, and that is the potential energy at point P, because at infinite its potential energy is 0. So that we write potential energy at the final point minus potential energy at the initial point. Initial point means at infinite. That means finally we get, that is the potential energy at the final point. At the final point means that is at point P. And this is the definition, this is the expression of the electrostatic potential energy. And this is all about your electrostatic potential energy difference and electrostatic potential energy. And in the next video, we will discuss about another new topic, that is electrostatic potential and electrostatic potential difference not potential energy, that is electrostatic potential. Clear? Thank you.